Okay, so yeah, thank you very much for attending this talk. What we're going to do in this talk is to present to you how you can reduce or you can identify risk in your supply chain using OWASP Dependency Track, which is a flagship OWASP project. I'm Niklas. I work for Control Plane. I'm the co-maintainer of Dependency Track, and I'm also a contributor to the CycloneDX project of OWASP. I mostly maintain the official Golang tooling for that project, and I'm joined by Vinod and Neha, who will introduce themselves.
Hey all, I'm Vinod. I'm an AppSec professional. I like to work on open source projects, standards, and community. That's one of the main reasons I'm here today. Yeah, thank you.
Hello everyone, good afternoon. My name is Meha, and I've been in the software industry for like 9 years now with work in both development and testing. I joined AppSec because of Vinod, and I'm really enjoying my work in this space. So yeah, let's go.
Thanks both Vinod and Neha. So yeah, a quick look at the agenda, what we're going to look at today. This talk is about a specific tool, and to understand what this specific tool is designed to solve, the problems it's designed to solve, we first have to set the scene a little bit. And in doing this will also involve us taking a look at the overall supply chain security landscape. We will then narrow down our focus on the inventory part of this thing, which also brings us to the bill of materials. Maybe I should advance the slide so you can see what I'm talking about. So we will also touch on the bill of materials part of the story, but also on once we've established this groundwork, we will then demonstrate to you what Dependency Track can do, what it is, what the problems are it is designed to solve, and at the very end we have a little teaser of some sorts that we hope you will enjoy. Yeah, but first, setting the scene. I'm very sure you've seen this image countless of times in this context, but we've chosen to use it here again because it describes the current situation very well. The software we built and ship today is made up mostly of third-party components for various reasons, right? Like faster time to market, no need to reinvent the wheel, you know the things. And Synopsys published a report last year where they assessed over 2,400 commercial code bases, and they found that the primary part of those contained open source software. That alone is not that big of a deal, but they also found that 78% of those code bases were made up of open source software. And that is 78% of code that the maintainer or the final manufacturer of the code does not have control over, but they still ship the code. It's still, they slap their logo on it, it's their problem in the end. And the further down you look into the dependency tree or into the tree of your dependencies, the less you tend to know about the components that are hiding in the deep. Because most of the time you only define your top level dependencies in your Maven POM, in your package.json, in your requirements.txt, but you're missing the whole part of the transitive dependencies. And many organizations lack the transparency within that. And what's important to say is, yes, these statistics are aimed at open source, but this is not specifically an open source problem. You may just as well depend on commercial stuff, and even commercial stuff will bring other commercial stuff with it and other open source stuff. And the problem of missing transparency remains the same overall. So overall, I think it's fair to say that the supply chains that we have today that we are dealing with are pretty similar to what the real world is dealing with. Granted, you will probably not have resource shortages because libraries are available en masse. There are probably too many, depending on how you view it. But the whole supply chain, right? It's just as strong as its weakest link. And if you have hundreds or thousands or even hundreds of thousands of links in your supply chain, the odds of the one or the other weak one being among them is very, very high, or higher than you would like to admit. And it turns out that these complex supply chains offer an attack surface that is pretty much or almost absurdly big. It's crazy. So that even organizations that have the common security best practices in place or best practices and solutions and all the cool, fancy products, even they fall victim to very simple attacks or comparatively simple attacks. And one of the first examples that come to mind is, of course, the log4shell vulnerability. Of all possible attack vectors, who could have possibly predicted the logging library to be the culprit of big enterprises being breached? Quick show of hands. Who of you was involved in remediation of log4shell? That is quite a lot. I'm feeling with you. Keep your hands up, please, if you felt like the organization was well prepared for a situation like this. There are a few hands. I'm very envious of you. How did you do it?
Java.
Java?
No, Java.
Oh, that's a good, yeah. We should have more of those, yeah. Anyone else?
Well, we literally have dependency tracks here.
Oh, that's cool. They have dependency track. That's a cool strategy. Okay, so one of the things that made log4shell so incredibly painful was how easy it was to exploit, right? You could just scan the entire internet, and in just a few seconds, you had a few RCEs going for you. And given the criticality and the ease of exploitability, you would probably have expected this the patching to be a quick process, right? The patch is released, everyone patches it, thing is over. But not really. Because according to the statistics provided by Sonatype in their annual State of the Supply Chain report, which I very much recommend you read, I added the QR code. I just learned from Spiros that QR codes are among the security practitioners, but maybe you want to give it a go either way. So according to them, Sonatype operates Maven Central, by the way, which is the biggest or the primary Maven or Java package repository in the internet. And they have insights that others do not have. And what they found is that almost 1 year after the release or the vulnerability being published, there are still a lot of projects, namely around 30% of projects pulling in vulnerable log4j versions. And referring back to even though patched versions were available almost immediately, what this clearly shows is that most of the log4j users, or 30% as I just said, either do not care, are not able to patch because it turns out to be too difficult for some reason. Maybe they depend on another commercial software suite and they can't patch, or they have no idea they're even using it, which is the even bigger problem. And referring back to the iceberg slide I showed at the very beginning, logging libraries are oftentimes things that you don't directly see, right? Some library pulls them in, you do not directly depend on them most of the time. And cases like log4shell are just one of the many possibilities that supply chains can be compromised, right? Also in Sonatype's report, they conclude an average year-over-year growth of so-called next generation supply chain attacks since 2019 of 742%. And next generation supply chain attacks refer to attacks where attackers actively inject malicious code into supply chains or publish malicious packages and make you depend on them in one way or the other. So they take the matters in their own hands now. They don't even have to rely on known vulnerabilities being published. And 742% growth rate, are you crazy? That's insane. So the problem of these attacks, of course, is that you will probably not find them in your security scanners. So yeah, clearly a huge problem that needs to be tackled. But there's all this complexity, all these dependencies, and so many things that can go wrong that it's easy to get lost in this topic. It's very overwhelming, and looking at this from the outside, it can feel like being stuck in a maze, right? You have no way of getting out. And in fact, as so often in security, it helps to take a step back and take an holistic approach to the problem. And just to name a few things that you probably should be doing in this space, just a few snippets, if you will. You're curing your packages or like selecting your libraries before you depend on them. No matter how realistic this is in practice, but you probably should be doing it. Then ensuring that your source code, the build environment, and the build artifacts have not been tampered with. inventorizing the components you depend on, especially those components that you ship with your product, also continuously analyzing that inventory that you built and verifying that what you're about to deploy is in fact what you want to deploy. Just a few examples. But yeah, as I said, it is a lot, and that is why luckily at OWASP we have this cool project named the Software Component Verification Standard, which is led by Steve Springett. You will hear this name more often in this talk. And similar to the ASVS, the Application Security Verification Standard, the SCVS provides a set of control families and requirements within them that help you to, or that you can use to either benchmark yourself, your organization, or the suppliers to your organization against, or you can take it as guidance on where and how you can progress from where we are right now. Again, similar to the ASVS. So if you're in a situation where you don't really know, or where you know you have to start looking at this topic, but you don't know where to start, the SCVS is a great place to start and great place to look into what you can do. A lot of the hot topics and buzzwords that you hear in the space, be it SBOM, be it VEX, be it BDR, something like this, all of the things that you hear in the space are just the means of implementing some requirement, right? And what you shouldn't do, what you definitely shouldn't be doing, is implementing stuff before you know why you're doing it. So standards like the SCVS really help you in getting a grip of what you need to do, and then you can apply the tooling, then you can install tools. And yeah, this also obviously applies to the tool that we are demonstrating today. Be aware that what you're using it for. Incidentally, what we will touch on today are 3 of the 6 control families in this standard, namely the inventory, the software bill of materials, and the component analysis part. So, what is inventory and why should you care? One of the golden rules of InfoSec, of course, is you can't protect what you don't know exists, right? That's one of the most popular rules in InfoSec. And similar to how an inventory of servers, domains, etc. is critical to assessing your attack surface from the outside. By the way, shout out to the OWASP AMS project. Who uses OWASP AMS? Anyone? That are way too few hands. You should know about OWASP AMS, sorry. It's an attack surface, sorry? AMS, yeah. AMAS if you're in German, probably. Yeah. It's an attack surface discovery tool. You can discover domains, IP addresses with it. Please check it out. But yeah, back to this topic. The same principle of managing attack surface applies to the components in your applications as well, obviously. But an inventory of your packages is not what you will find in your typical package repository, like Artifactory or Nexus Repository Manager, because just because packages are available doesn't mean you use them or they are even deployed in production. Also, an inventory should contain third-party software. If you are buying software from a vendor, this software should be part of your inventory too, and the components this software depends on as well. So having an accurate and complete inventory is crucial for identifying risk in your supply chain. It's kind of simple. And one of those risks, or one of the most obvious risks in your supply chain, are known vulnerabilities. Of course, if there's a new CVE in your libraries that you use, you want to be notified about it so you can start your remediation efforts. This is pretty much the whole selling point of most of the SCA landscape that we have today. But as we all had to learn, not every vulnerability has an identifier immediately when it gets known. Right, we've all been there at some point, scrolling through Twitter on a Friday afternoon, when suddenly something like this gets retweeted into your timeline, a random account dropping a supposed 0-day, even with a POC, a proof of concept code along with it, which is pretty cool. Proof of concepts are nice. Proof of POC or get GTFO, I shouldn't use the full sentence, I guess. So yeah, you see this post. What do? Are you just going to wait until there's a CVE for it so your scanners will pick it up? Or are you betting the odds that this is just a hoax and you can skip on it altogether? Probably not, right? The question you are probably being asked or asking yourself is, am I affected and where am I affected? And this is again where inventory comes into play. Assessing the impact of even unknown vulnerabilities is only possible with a complete and accurate inventory of components. But there are other risk factors as well, right? How about licenses? If your company offers a product or sells a product as a service and you depend on components that are AGPL licensed, you probably shouldn't be making money with this product, or you shouldn't be selling it, because the AGPL would then require you to open source the source code. Component H probably is this. Yeah, component H. So have you ever looked at a project and the project had like 10-year-old libraries in it, right? Have you ever seen this and then said to yourself, well, I'm very happy to run this in my infrastructure, and this will of course be a very easy thing to maintain over time? Probably not, right? Because even old components are lacking the security and stability patches. So yeah, and at some point, components even get end of life if they are too old, if they are abandoned. Abandonware is a thing. So having to patch end of life components on a Friday evening, just before the holidays, or even having to replace these components just because they are now affected by a critical vulnerability, is one of the least fun experiences that you can have. And also, maybe your organization has policies. Policies could be as simple as do not use any non-permissive licenses, but they could be complexer. For example, in internet-facing applications that are critical to the business, do not allow for vulnerabilities with a high severity or components that are older than 2 years. That is a very valid policy to have. So now we understand that inventory is important, what you can do with it, and what the consequences of lacking monitoring of the inventory are. But how do you actually build an inventory? I already mentioned that package repositories do not necessarily provide the type of information that we want. We also have a need to include the software of third-party vendors. Not only the software we build ourselves, and package managers are so different from one another that just sharing the build manifests is not really productive, right? You can't just share your POM XML or package JSON with someone else. That's not really practical. Instead, what we need is a detailed list, a snapshot of sorts, in a well-defined format, so that we can use software, or we can build software around it and processes around it. And this is where bill of materials come into play. Bill of materials is a concept that you run into in the larger, broader engineering space more often. And it turns out that this does apply very well to the software supply chain security space as well. Because what physical components and raw materials are in the real world are libraries and frameworks in our world, in the digital world. So the adoption of BOM to the software is surprisingly called software bill of materials. Who could have known? And it is a way to describe what's inside a piece of software. And it's supposed to be a complete, accurate, and machine-readable inventory of all the components and the dependencies of those components in a given product. SBOMs in general are not a silver bullet. They are just a means of achieving transparency. And transparency is one of the preconditions for building effective inventories. There are also a few nuances as to when you generate SBOMs. I'm not going to open this can of worms today, purposefully. But I just will say that in general, you want to stay as close to the build as possible, because information is not there yet when you just look at the source code, and information will be lost after the build. What you can do is you can enrich an SBOM in multiple stages if you want. For example, you can generate an SBOM at build time and then enrich it at runtime, for example, if you have a Java agent, for example. And then you can also, if you wanted, filter components out that are not used at runtime. Yep. So, as in many other areas, like I touched on OWASP AMS already, SCVS, OWASP has you covered in the bill of materials space. And the project I'm talking about is CycloneDX. And CycloneDX is a full stack bill of materials standard. It's an OWASP flagship project. And it is full stack because it acknowledges that modern supply chains are made up of much more than just third-party components or libraries. So what you can do with CycloneDX is you can not only represent SBOMs, but also software as a service BOMs. So bill of materials that describe services interacting with each other, or hardware bill of materials. So how is my device, of what is my device being built or made up of? Or operational bill of materials. What kind of applications have I deployed in my production environment? Also with CycloneDX, as you can see on this graph, there are also the words VEX and VDR, which are kind of a hot topic in this space at the moment. Steve Springer published a blog post on the OWASP blog a few days ago, where he explains the differences between VEX and VDR. VEX is, for those who don't know, the vulnerability exploitability exchange. It's a means of describing when you are not affected by something. At least that's what it's marketed as a negative security advisory. VDR would be another way of putting the same information, but with a little bit more, I guess. So in VDR, you as a vendor give a statement of, hey, I checked my software, all the components within it for vulnerabilities, and I found either no vulnerabilities or I found vulnerabilities, and this is how I'm going to fix it. Whereas VEX will be focused on a project or a product, but not on the components within it. And it will also only contain the analyses or the details for the findings that you actually had, and not only those, or not also those for those components that were not vulnerable. There are, of course, other SBOM standards, like SPDX, for example, or probably also SWIT. I'm not sure if that's used in the real world. And we definitely encourage you to look into those as well. But for the time being and for this specific talk, we would just keep it to CycloneDX for now, just to keep it simple. But just know they are out there as well. A quick run through of the elements that you can represent in a CycloneDX bill of materials. There is the metadata section where you would describe what am I actually describing in this bill of materials, who made it, who produced the BOM, who manufactured it, who published it, etc. Then also the components, what's inside the thing I'm describing. And as I said before, CycloneDX is full stack, so you can not only describe libraries, frameworks, you can also describe devices or even files if you want. Even services. Because it turns out even services like REST APIs are part of your supply chain. If you use an external service in your product, for example, for stack exchange values or health data, I don't know, then even that is part of your supply chain. And it should be captured in a bill of materials. And of course, you can express dependency relationships, how your components and services depend from one another. Also, compositions. Compositions allow you to describe how complete a given set of data is. For example, this allows you to say, I know my dependency tree up to level 3, but everything that comes below that, I don't know. Known unknowns, if you will. There's also vulnerability data, and vulnerability data can not only include the descriptions or severities or risk ratings, if you will, but also analyses. And these analyses could, for example, say, I'm not affected by this thing. And this again feeds back into the VEX versus VDR thing that allows you to share this data. And if all this isn't enough, you can also extend the bill of materials with custom properties or XML extensions if you want. And a minimal SBOM in CycloneDX should contain metadata, components, and properties. And with this information, it is trivial to build an inventory of software that you use in your organization. And with the supported formats, JSON, XML, and protobuf, it is also practical to share this information across multiple channels. So yeah, now that we know of inventory, BOMs, and SBOMs, and how you can use those, we are still kind of missing a critical part in this whole story, and this is dependency track itself. And this is where I hand over to Meha.
Thank you. So So far, we saw how dynamic the world of software supply chain is, and we saw from the stats how vulnerable we could be if we are not looking at it all the time. So we definitely need a tool that will keep an eye on this for us at all times, maybe. And it has to be as automated as possible because we don't know when the next RCE incident is going to strike us and our repositories. So today I am here to talk to you about dependency track and what features it brings across to the table and will make you feel interested to use it in your supply chain security toolset. So dependency track is not only an inventory of the components of your application, but it helps you keep continuous monitor it and track those components so that whatever projects and components you have, if they are vulnerable in any way or if they are violating certain conditions, they are posing a risk to the project as well as contributing to the overall risk of that the organization itself is facing. So dependency track will help you deal with that level of detail. Just before delving into the features itself, here is some history about the application. So dependency track was developed by Steve Springett in 2013, and this year is the 10-year anniversary of dependency track. And the Cyclone DX format was originally designed to work with dependency track in 2017, and today it is a widely adopted standard used by different SBOM generation and processing tools. Now, when we talk about supply chain security, there are multiple questions or concerns that everyone can have. Is there a way I can get vulnerability information from multiple sources in one place? Is the tool that I am using providing enough information? Is there some vulnerabilities or information I am missing out? If I have all the vulnerabilities with me, is there a way I can prioritize the mitigation? Like you just have lots of information to work with, but you don't know what order to track it down. There might be policies in your organization that you want to enforce, and is it possible to do that in some platform? Also, it's not just components that you are targeting for vulnerabilities, but you also want to see where exactly was it introduced in the dependency tree of your application. So dependency track has answers to all of these questions, and also through that you can send notifications and information to any downstream systems and communication channels because it allows you to connect to multiple of them as well. So let's go into the demo. I just want to mirror my screen, so 1 second. Can you help me? Can you mirror my screen so I can... Probably open over there.
You want to put it in that screen and show?
Here also.
Sure.
Maybe.
Let's see what we can try.
1 second, I will give it a try. Oh. Should I? Sorry, we are just trying to mirror screens so I can demo the thing properly.
I can't see the mic.
Thank you. Thank you. So, yeah. Coming back to the discussion now. So as you log in, this is the dependency track UI. And as you log into the application, this is the first dashboard that we will be able to see. And there are some quick metrics that people or stakeholders might be interested in. So the overall portfolio vulnerabilities, projects at risk, vulnerable components, etc. And by portfolio, we mean all the projects that are currently being scanned or being tracked by this instance of dependency track. The next thing to look at is the projects tab itself. So this is where dependency track would allow you to create projects by giving them a name, a classifier, and maybe some tags. Maybe some of your applications are critical, or they are client facing, or they are just internal, and you can provide the required tag if you want. And once the project is created, you can have something like this, the Peanuts project. And if you go inside, I have already got some components in this project. It is possible to upload an existing SBOM into this project itself, or download what is already available on dependency track now. We talked about being able to have vulnerability information from multiple sources, and that and multiple other configurations are available through the administration tab. So over here, there are analyzers that you can configure. So for example, there are 4 currently available. And for today's demo, I have the OSS index and sneak is enabled. So for example, the OSS index one, I just have to provide the ID and token and enable it and say update. This would, enable this scanner for any of the projects that would be uploaded after enabling it. Also, dependency track allows you to scan projects on a scheduled basis, which we will also see later in the demo. That time, this scanner would be used. Again, vulnerability sources are also multiple, and you can, by choice, enable or disable it as you want. So for today's demo, I have the Google OSV advisories set over here. To enable this one, you simply have to select the ecosystems you want to get the advisories mirrored for, and then say select that and click update, and that would enable the OSV advisories mirror for you. Now, once you have all this vulnerability sources configured and you're ready to go, you also want to set some alerts that you would want to let downstream systems know about. So that can be done over here in the notifications and alerts. And for example, for today, I have got 2 alerts configured. One would be for SBOMs consumed and processed, and that is going to an outbound webhook. And we will be seeing notifications on that shortly. Again, I have got another alert enabled, which is for vulnerabilities and policies violations. And again, that one is going to a second outbound webhook. Also, regarding policies itself, this is where you can create new policies or manage existing ones. So for example, I have this critical findings policy created, which is saying that the violation state would be a failure, and the condition that it is gauging the projects for is severity being critical. And it is also possible to limit this findings policy to specific projects that could be done from here, or specific tags that I have done, for example, this one. So this is again one of the tags I had added to the project we saw earlier. And if you want to add more, you basically come to this list and enable or disable existing tags. So this is how the UI looks like, but we also said that we want the analysis automated to some extent. And there are multiple ways in which you can integrate a dependency track into your CI/CD pipelines, for example. And one of those ways is to use the dependency track Maven plugin, which I will be using today. So for demo, I have got this small project as an example, which is called Test Maven project. And that is the snapshot version of it. And I have got dependency track Maven plugin also added here. Yeah. So in order to use this plugin, I have to provide the URL of the API server of my instance that I was using, and also a token that was generated locally for this connection. And once I have that, I can also provide a polling config, which is allowing the application to poll until the SBOM that was uploaded has been processed by DT or not. So we are talking about SBOM upload, but we need an SBOM to be uploaded. And for that, I have used the Cyclone DX Maven plugin as well in this project. And I have the BOM already generated for myself. Can anyone tell me what command I would be using to upload the SBOM? Any guesses? No, easier than that. Yeah. No, it is as easy as saying upload BOM. So yeah, that is the command I am using. And additionally, I have got some arguments, and that is for the polling config we saw earlier. So as I trigger that, the token is used to integrate with the instance of dependency track I was showing. And it is saying still processing, and that is because it is waiting for the analysis to complete for that SBOM. And if we go to the UI also, here this project has been created with the same name we had in the POM of the project, and the version is this coming from POM as well. And now it says that the analysis is complete and the build is a success. So if we go into the details now, we can see there is components for the project, there is a dependency graph, there are some vulnerabilities found, and so on. So going to each of these one by one, in the components tab, yes, we can see all the components of the project. And if you click on this small tree icon next to the project specific component, you just land into the exact place where the component has been introduced in the dependency graph. And similarly, even in the vulnerabilities tab, you can have go to the exact place where your vulnerable component was introduced in the graph. And with the latest release of dependency track, you are able to view the whole dependency tree of the project in this tab. It's in the previous releases, it was limited to 3 levels, but now you can view the whole tree here. Going back to the audit vulnerabilities tab, here there is another triangular icon. And like Nicholas was mentioning before, we don't want to use components that are getting outdated. You don't want to wait until they are like out of support, so you don't know what to do with that. So dependency track helps you with this, like it is highlighting the outdated components as well as telling what version would be useful to upgrade to. Vulnerabilities, now those are coming from multiple sources, as we can see with the tags next to them. So there is vulnerability coming from NVD, Sneak, OSS Index, as well as GitHub. Now there are two things about this information. So one is like there are some vulnerabilities which were found by one source but not by the other, which makes you feel more protected or covered with using dependency track. And the other aspect of this is that there might be some vulnerabilities found by multiple sources. And again, that information, the vulnerabilities itself would have different descriptions and risk scorings, but they are essentially the same. So you don't want to be bombarded with duplicates in the analysis as well as in your risk score or the overall dashboard we saw earlier. So that is done by dependency track for you by finding out the aliases and telling this information not only here, but also in the notifications that are sent out. There is also support for exploit prediction scoring systems. So here we see that there is EPSS score for each vulnerability that was found, and you can prioritize the mitigation based on that. Now, currently there is no policy violated because even though we had some critical findings in my project, the project doesn't have the tag that I had limited the policy to. So there is no policy violation as such. Now, there is more that you can do with the plugin. There is also the possibility to just get the findings from the plugin itself without having to go to the portal. So for that, again, the command is as easy as saying dependency track findings. So once you execute that, if there is no threshold established by you for the project, you will simply get a summary of the findings that were found. But here in this project, I have got some threshold set and my build is also failing. And the reason is, like we can expect, the thresholds that I have set in this project are being violated by what the counts are on the portal. So this gives you a way of failing your builds or gating your projects with just the findings themselves. And there is a similar command for policy violations also. So that is called dependency track policy violations. And currently there is none, but if you have some policies being violated, again, the project build will fail because now you have some policy violations in the detected by dependency track, and those are getting reported in the plugin as well. So this is all great, but what else can you do? We talked about zero-day attacks before. So dependency track comes at your help with this, and if you are using it, the next time there is a zero-day attack, maybe you will be able to solve it more efficiently and manage it in a better way rather than maybe have to run around for help and try to find what is happening in the repositories and what is getting impacted. So for that, again, policies is one of the ways you can go. Considering the log4 shell example itself, in the policies, if you go and create a policy which says maybe upcoming Spring 4 shell policy, and we go create that. Now, one of the things that was known for the log4 shell zero-day attack was that it was affecting Spring Web MVC packages from versions 5.3.0 to 5.3.17. So one of the criteria of your policy could be that if the projects being scanned have a component whose Perl or package URL matches one of those, you can flag that project for a policy violation and take it from there. So I can use that over here, and that would be through package URL matches 5.3.0, for example. And the same way I can add more over here, but to keep it short, let's just have one. And in my project itself, right here, I have a direct dependency added for that. So we can see that the Spring Web MVC 5.3.0 is being used. And the next time you run the scan on this project through dependency track, the analysis would be done again, and we would be able to see policies being violated, and that is how even your build will fail if you, for example, were using the dependency track Maven plugin. And here you can see what condition had failed, as well as audit that particular policy violation as needed. So yeah, that being said, there is another condition which we frequently face, and that is regarding malicious packages. And one of the biggest targets, as I know of it, is the Node package manager. And there are multiple packages that for which we may not be sure if the integrity of the package is maintained. So regarding all of that, one of the examples that comes to mind is the UA parser JS attack that had happened in 2021. And why it led to a supply chain attack was that the number of downloads of that is nearly millions every week, and it is being used by multiple applications. Now, this is another case where you don't have like CVEs defined for it, or how do you track this situation? And maybe SCA tools are not sufficient here, or maybe they are. But anyway, with dependency track, again, policy management comes to help here as well. And you can define another policy which will match the hashes of your components being used with the hashes that you say, okay, this is a malicious hash, and I want to check whether my applications is using components with that hash value. And let's say add that here, and all you have to do is say, I am failing it for everything, but you can as well just do inform. And there is a component hash that you can add, and SHA 512. I have an example for that value, so I will use it. Let's say that. And if I go back to my NPM project here, this is an NPM project, and it is already violating 9 policies here. And if I did do a rescan, I have a dependency added for that particular hash to be violated, and we would be able to see the changes and getting reflected here, as well as for your builds. So all this is happening manually, like I triggered it multiple times while we were talking. But like I said before, it is also scheduled functions that dependency track can do for you. And again, we can configure it in the administration tab. So in the task scheduler, one of the things I mentioned was vulnerability analysis is happening once in every 24 hours for all the projects that are already there in the portfolio. So you can either use this, or you can configure it to the value that suits your requirement. So that is it from me. But there are a lot more other features of dependency track and lot more you can actually help us with or contribute to if you are interested. And I would like Vinod to come and talk to you further about it.
Thanks, man. Yeah, I'm not going to try to go through everything, but yeah, we have literally 5 minutes remaining, so apologies in advance. We won't have enough time for questions, but we will be here after the event. You can come and ask us directly question today, and tomorrow we are happy to answer your question. So as you have heard and seen today from Nicholas and Meha, dependency track does a lot of things, and there is even more things that we were not able to show today because of the time constraints, as you can see. So these feature set that dependency track offers make it very interesting for large enterprises. But one of the big challenges is that large enterprise operates in a big scale, and most of the time they need tools and services that can scale very well with their inventory. Most of the time the large enterprise will have tens or hundreds of thousands of applications, and they need to keep track, they need to enforce, they need to monitor all these projects. So at this point, the current version of dependency track is not horizontally scalable. So what we have decided is, okay, let's take the current version of dependency track and scale it and make it even usable for large enterprise. So that's what we did with the Project Hades. So Project Hades, technically, we took the current version of dependency track and they sliced or divided into multiple domain-based services, which can be scaled independently and which can also communicate via distributed streaming platform like Kafka. So we use Kafka heavily in the Hades project. So it's a Kafka focus or Kafka protocol focus. So even if you have Red Panda or Kafka protocol compatible streaming platform, you can still use it with that. So we do have an initial version of the project available, so you can find it in the GitHub under dependency track repository, dependency track organization called a Hades repo. Yeah, so we are interested to hear all forms of feedback on this project, and we are also welcoming all kind of contribution to the project. Oh, sorry. Yeah. So we hope that with Hades, I mean, we have already did some level of load testing and everything, and we have proven that it can handle the large loads that large enterprises may have. So at this moment, I would like to thank Steve Springer, Alion, Sahiba, Apurva, she's not here, and Vitika also is not here, and all others whose efforts and support, made this happen, the Hades project. That's it. Over to you, Nicholas.
Oops. Hiding the notes. Yeah, now finally, it's your turn in some sense, because all of the projects that we demonstrated today, or that we showed today, are all community projects, right? And as Spiros also said today, we need your contributions, otherwise these projects will not survive. And if anything of what we told you about today was appealing to you, if anything of these things that you would like to contribute to, we would be more than happy for you to do that. We are here, as Vinod said. We will be here for your questions, for your inquiries. If you have any questions, we will try to answer them to our best knowledge. Yeah, I guess that's it. Your turn.